Hi, welcome to part 4 of the max or mins. We're basically doing some examples, algebraically finding when the graphs have the highest and lowest points. And we've been doing it by taking the derivative and setting the derivative equal to 0 because we're using the idea that when you're a max or min, you're leveling off and you would have a tangent that would have a slope of 0. So that's what we've been using. Now, for this particular example that I have here, there's a little bit of a trick problem to it. And so I just want to bring it to your attention right away so that way when we do the process again, it'll come evident. And so I don't want to surprise or trick anybody, so I'm just going to be upfront about it. And so what I'm looking at here is this type of graph. This graph right here, when it goes to the left, will curve back up and go to positive infinity. And so this graph looks like a minimum here at 0. And so then it increases, and then it kind of starts leveling off here at 2. But it doesn't come back down to create a maximum. It then keeps on going up. So what we have here was an increasing situation up to 2, had a potential for being a max, but instead of coming back down, curving down, this graph was going back up, or continues to go up rather than comes down. And so what we want to do is look at what's happening here at 2. This is going to be the interesting part for this problem. Why doesn't this graph have a maximum? What's this leveling off here and then continues to get larger? So we'll be playing with that. We'll be exploring that. Okay, so to find our max or mins, basically our step here is to find the critical values, those critical points, and we do that by taking the derivative. We do it by setting it equal to 0, and then we clean it up a little bit. We're solving for it. I basically took a 12q and factored it out. I got a q minus 2 to the power 2 left over. So I took a 12q out of these three terms. I ended up with something that I could actually factor further, and that's where I'm getting this q minus 12 quantity squared. Set each one equal to 0, and you come up with these two critical values. Now, what you see here is I'm listing a 0, 2, and a 2 here. Why am I doing that? Is because when I do 12q equal to 0, I get q equals 0. But when I get q minus 2 squared, I get really 2 twice. Because of that power 2, I get this repeated roots in a sense. And so that's why I'm listing them. Also, I have a daughter who does ballet, and so she really likes it when I could do something with a 2-2. Get it? Her 2-2 for ballet. Okay, bad jokes. They don't pay me for the jokes, just for the math. Okay, so those are our critical values, 0, 2, and we got a repeated 2. And so then what we're doing is we're checking for our intervals for increasing, decreasing. We're using our derivative. We're using our critical values. We're making our number line. Our critical values separate our number line into sections, into intervals. We have 3 sections here. What we want to do then is pick a number. Oh yeah, and then plug it into the derivative. But the derivative I want to use is the actual simplified, the factored form. The reason being is because we're finding the derivative is positive and negative. We're not finding the actual numbers of our derivative values. We're just looking at for when it's positive or negative. And so the factored form of our derivative actually makes it easier to find whether it's positive or negative. I'll show you in a second. So let's take this third section here, the one on the left, excuse me, and I'm picking a number. I'm picking negative 10,000. I'm plugging it into the q value here. But you know what? Negative 10,000 minus 2 squared is going to end up being a positive number. Going to be a huge positive number, but it's positive. And so it's always going to be positive. This part's always positive. So whether I get a result, end result that's positive or negative, all depends on the 12q. And so when I do the negative 10,000 there, I get negative 120,000 here times a positive number, still end up being a negative number. So for any number that we pick in the left section here, we're going to end up with a negative result for our derivative, because this is going to be a power 2, and it's the 12q that would make it negative. Then we go to the middle section. You pick a number out of your middle section, you plug it into it, and guess what? We get a positive result here and a positive result here. And so our overall value for the derivative will be positive. And then I pick a number way out here on the right section. I'm picking 2064. Why? Because, hey, it just sounded like a cool number to use. So I take 2064, and then basically what I do is we plug it in. This will be positive because it's a power 2, and then this will be positive. And so we end up with overall being positive for our derivative. So that means we got positive for every single number in there. So what does that mean? For the left section here, we will have a result for our derivative being negative. That means the original guy will be decreasing for that section. For the middle section, our derivative values will end up being positive, so that means our original graph will be increasing. And then for the right section here, everybody will have a positive value for our derivative, so that means we're increasing as well. So what we have here is we have a decreasing, increasing, increasing type of graph. That means we're going to have a minimum here at 0 because we decrease and then we increase. That creates a minimum. At q equals 2, we're increasing and then we increase again. We don't have a minimum, we don't have a maximum. We'll have something what we call a saddle point. That's where we increase, kind of level off, and then we increase again. And so that's what's happening here at 2. So then when we do our checking with our endpoints and stuff like that, they're infinities, and so we're just looking at the limits because we're not really technically allowed to plug in infinity and find the values. We're doing our limits, and so when you do limits, when you go into infinities, you're looking at the leading term, and because it's a power 4, that means whatever number we plug in, a negative a billion, negative trillion kind of thing. Because of the power 4, it's even. We're going to end up with a positive result here. And so that's why in both cases we have going to infinity. That means our graph to the left and right, far left and far right, it's going up. Now, for our next part here is that when I plug in the critical values 0 and 2, we end up with a value of 1 and a value of 17. Now remember that this guy right here is going to be our minimum, and it ends up being our absolute minimum. It's the lowest y value possible. And then the 17, remember that we had an increasing situation here around 2. That's not a max or min. It's what I'm going to call a saddle point. And so what we have here is on the left and right side, we have no max or mins. We have an absolute minimum at 0, and then we have a saddle point at 2, because that's what's happening to this graph. On the left-hand side, just keeps on going up, and then to the right part of the graph, it goes up. Here at 0, we have a minimum, absolute minimum, and then we level off. We increase to 2. We start leveling off at 2, but then we do not go back down, so that means not a maximum. We level off at 2, and then we start going back up again, and that's where we have increasing, increasing, creates this little saddle kind of situation here. And so hopefully didn't confuse you too much on this example. I was trying to kind of vary it up a little bit so that you'd be prepared for this type of situations. So always be looking forward, be careful of your repeated solutions for your derivatives. Thanks and have a good day.